All semester, we've been leading up to this: chemical reactions. Chemical reactions are changes in matter that result in something new. I don't mean just a new form, like how liquid water will change to ice. I mean something fundamentally new, like how you can burn a piece of wood in a campfire and turn it into ash, carbon dioxide, and water. Ash, water, and carbon dioxide are not other forms of wood. They are new things created through this reaction. Now, if you think back to when we first learned about the atom, we learned that atoms can neither be created nor destroyed during a chemical reaction. That was a key point introduced by John Dalton. This tells us that in any chemical reaction, everything new that is created has to be made from the pieces of the starting components. Since the atoms from the original substance can't be destroyed, and the atoms that make up the new substance can't be created, the atoms must get rearranged to create the new substances. Let's see how this works using a simple combustion reaction. What happens when something burns? Here we have methane. It is one carbon atom bonded through covalent bonds to 4 hydrogen atoms. When you burn it, you're starting a chemical reaction between the methane and oxygen gas. The oxygen gas breaks apart and pulls the hydrogen atoms off of the carbon, making water. A second oxygen gas molecule breaks apart and attaches to the remaining carbon atom, creating a molecule of carbon dioxide. This is an example of a chemical reaction. We can describe this chemical reaction to others by using what scientists call a chemical equation. A chemical equation is broken up into 2 parts: the reactants and the products. Reactants are the ingredients needed to perform the reaction. They are what is actually reacting. The products are what you end up with in the end. They are what is produced by the reaction. When writing a chemical equation, we use the chemical formulas of the substances involved, an arrow to show which substances are the reactants and which are the products, and plus signs to separate chemical formulas when there is more than one reactant or product involved. Chemical equations also use coefficients to indicate when more than one molecule of a substance is present in the reaction. If we didn't use coefficients, then the chemical equation would be unbalanced, meaning that the amount of a specific type of atom in the reaction wouldn't be the same on both sides of the arrow. In chemistry, we think of this arrow as an equal sign. Just like in math class, both sides of the equal sign, or arrow, have to be balanced, have to have the same number of atoms. Let's look at another reaction and its chemical equation. Let's look at the reaction between baking soda, NaHCO3, and vinegar, also known as acetic acid, C2H4O2. When these substances react, they create something called sodium acetate, NaC2H4O2, along with carbon dioxide, CO2, and water, H2O. When writing this as a chemical equation, we typically write the reactants on the left of the arrow, separated by plus signs, and the products on the right side of the arrow, separated by plus signs. The arrow always shows the direction of the reaction, pointing to the products. All right, let's look at some examples. What are the reactants in question number 1? Because C5H12 and O2 are the things that are reacting, that makes them the reactants. CO2 and H2O are formed in the reaction, that makes them the products. Now, is this equation balanced? Let's find out. All right, so here we have oxygen, and it is taking 4 of the hydrogens off of that first molecule. Keeps going until we have 6 waters, 5 carbon dioxides, and we used a total of 8 oxygen molecules. The big numbers we wrote in at the end, those are our coefficients. That tells us how many of each molecule are in the reaction. Let's try another one. For the chemical equation above, What are the reactants? What are the products? And is it balanced? We know that this is balanced because it has the same number of sodium in the reactants and the products. It has the same number of oxygen in the reactants and the products. And it has the same number of hydrogen in the reactants and the products. That means that nothing was created or destroyed in the reaction, and both sides of the equation are balanced. Let's do one more. For the chemical equation, what are the reactants? What are the products? And is it balanced? This is an example where the chemical equation is unbalanced. We clearly see that there are far more sulfur atoms in the reactant side than the products, and there are far more fluorine atoms in the products than the reactants. This formula can be balanced by adding the appropriate coefficients to increase the number of molecules involved in the reaction. All right, it's time to summarize what we've learned. First, chemical reactions cause new molecules to be made, not just things changing from one state to another. 2, atoms cannot be created or destroyed in a chemical reaction. They just get rearranged to form the new things. 3, scientists communicate about chemical reactions using things called chemical equations. 4, chemical equations take the basic form of reactants on the left, followed by an arrow pointing right, products at the end. 5, reactants are what reacts. Those are the ingredients. Products are what are created. Finally, 6, chemical equations have to be balanced, meaning that any element that is in this equation has to be present in the same quantity, same amount in the reactants as it is in the products.